What's going on, guys? Welcome back. Sorry I've been gone for so long. I recently got a new developer job and I have been playing catch up for the past month, but we are back now and gonna have a lot of content coming. So let's jump right into this. Today we are going to learn how to make a Pygame clone of Zelda. So again, this is a super basic project, super basic game, but I'm gonna show you guys how it works here and what we've got. So there we go. And boom, so here we go. You play as Link up here in the top corner. The objective of the game is to kill Ganon, who is teleporting around the map. He spawns the Shadow Beasts every once in a while, so you gotta go get the wand here, and the Shadow Beasts are gonna come, and then you gotta shoot them, and they die. So we'll kill this guy with my... One sec. Alright, so anyways, you kill the Shadow Beasts, and then when all the Shadow Beasts are gone, you can actually attack Ganon. So give me a sec here just to clear these up. And there we go. So we're attacking Ganon. You see Ganon's health is dropping, the top right there. And boom, he's got 30 left. The reason you have to kill the Shadow Beast is because Ganon is invulnerable as long as there are Shadow Beasts on the map. So you got to get rid of these guys. Boom, and now we finish them off. Okay, so there we go. We won. Now essentially here, I'm going to show you guys a couple other little tricks you can do. So everything you can do, you can transform into the wolf. And then Midna comes and hangs out with you, and you can transform back into Link. You can also pick up and drop weapons. So we're gonna go pick up this wand here, and let's see. Oh, actually, I got the sword. One sec. Again, it's not perfect. There are little bugs still to work out here. This is hot off the press. But anyways, we're gonna go and grab this wand and drop that with the space bar. Anyways, so yeah, that is the general thing there. And then again, you see a wolf. I just think that's pretty cool. Okay, so anyways, that's the game. Yeah, so we're gonna dive right into how that was made, what the structure is like, how you can make your own game with Python and everything like that. So so if you guys have never made a game before, I'm gonna kind of walk through how I did that from the ground up so you guys can get an idea of what kind of structure you want to use when you create your own games. Okay, so let's go ahead here and start off with the grid. So the first thing you need to do when you're creating a game is create the tiled grid. So you guys can see, we'll load this up here. We have this grid across that has the grass, the dirt, and the water, okay? So that is the first thing that we're gonna focus on, how it was created, and this is that. So essentially there are the grid squares here, which are the dirt, the grass, the wall. Oh, there's a couple other things. I've got like some features that I was working on that are in there that I have not that I've not used, so they're just kind of hanging around in the code. I'm gonna link to that after, so if you guys want to open this up and like play with this a little bit on your own, play the game, or just like make modifications to it, like you're more than welcome to do so. It'd be super cool to work with you guys on this. So anyways, got these trees. So the class tree, this is our tree object template. We've got our sprite, which is Pygame is loading in the sprites that I picked out. Basically, you can search online and find a bunch of pixel art or whatever art you want to use for your game, and then that is going to be your sprites, which you then load into your script with pygame.image.load, and then we are using pygame.transform.scale to scale that image to whatever size we want specific for our game. So every object that you see in this game here, whether it be a tree, whether it be Link, whether it be Midna, the shield, Ganon, the portal, the shadow monsters, those are all objects, okay? So those are all, they each have their own classes, they each have their own unique attributes, and they each have their own images. They each have their own X and Y position on the grid, okay? So again, for starters here, we have our tree, load in the image, we have our X position and our Y position, okay? So moving on here, we have our temple. Again, the same thing, loading in the temple image, X and Y position for the grid. And you'll see these are smaller right now, but these get multiplied times the size of a grid square in order to determine where its position should be. So next up here, we have our trees, and we go ahead and create a list of randomly generated trees. They're all going to be in random locations. We load in the images for our textures here, and then we go ahead and we make our grid. So our grid is just a big list, okay? So it's just a long list of lists that are making up the grid squares that are in our game. So we've got things like grass, dirt, water, etc. Like I still have the wall images, but I didn't bother putting those in there. But yeah, you guys can add whatever images you want for your grid squares. Lava, whatever. Okay, so game dimensions, we've got like tile size of 50, you've got your map height and your map width. So that is the number of tiles that are going to be displayed. We've got our caption for our game, so pygame.display.setCaption links adventure, and then display surface pygame.display.setMode. This is creating your surface that your grid is rendered on, okay? So then that's the map width times the tile size by the map height times the tile size. So that's creating our 20 by 10 grid here. All right, and excuse me. And then we have these colors here as well. All right, so moving back here, now that we've got our basic grid layout set out, let's take a look at these things here. So we've got our heroes, our enemies, and our items, okay? So on heroes, we've got Link, we've got Midna, and then I just threw the orb in here as well because it damages the enemies. So we've got, again, we've got our image for Link, we've got our image for Midna, we have our position, X and Y. For the player, we have things like inventory, what weapon is currently armed, what is the health, mana, which is again like a feature I threw in there but I didn't include, and then the wolf transformation boolean. Okay, so if you are a wolf, then you have certain things, you move a little bit faster. If you're not a wolf, you don't, blah blah blah. Okay, so now we've got that. So these are classes for all our things, and again, for every object that you're putting in your game, you're making a class. Okay, so next on, moving up here, we have Ganon, Beast, and Portal. So Ganon is again loading in the image, X and Y position, health, whether or not he's vulnerable. So again, if there's no shadow beasts, he is vulnerable. If there are shadow beasts, then he's not vulnerable. So can take damage, can't take damage. Same for the beast here. Then we got a couple attributes that have to do with whether or not they should appear out of their portals or not, right? Because we have to see, you got to see when the beasts come up here, they've got these little portals that appear first. Let's see here. So there we go. Portal, moving through the frames, boom, and beast spawns. Okay. So that portal, by the way, I did make that portal. Pretty proud of myself. But this is the program. I was trying to make the wolf too, but it wasn't clearly not going as well. So this program is called Scratch, by the way. Just search for Scratch in Google or Scratch pixel art in Google. That'll be the first thing that comes up. If you guys want to make your pixel art, you go ahead and you just open up a new one. Yeah, we'll save. Wolf.sb2. This .sb2 extension, that's just for Scratch. So then if you, that's a specific file that the Scratch program opens up. And then so here we've got like this, you go ahead to costumes. We've got like these guys. So we just want to delete this cat. And then we just go ahead and convert to bitmap, right? And then once you're in bitmap, you can go ahead and do like, do this here. Click the color you want, and then you can place the little bits. You can zoom in so you can get a little more detailed here. Got like purple. Whatever. So anyways, that's the idea. So yeah, Scratch, if you want to make your own art for the games, use Scratch. You can make pixel art and then go ahead, download that, load it up into your game, and then do whatever animations you want. So that's that. As far as animations go for doing that, basically you want to put like several different iterations of the position of the of whatever you're making. So take, for example, Link here. So I did make these. These I found online, but essentially this is the idea. So you have like here, he's facing backwards, standing still, facing backwards with like his foot a little bit raised, facing backwards with his back foot raised back. And then as you are looping through that and updating Link's image, it's going to look like he's moving or walking, right? So that's that. I'll go into a little more detail about how that is done later. So we got that. Moving along here, items. So again, we have classes for each item. We have our sword, our wand, gold, shield, and bow. Again, you guys didn't see the bow and the gold. Those are just kind of in there. Or those are just, I had testing playing around with those, and I decided to leave them out for this video. But feel free when you guys grab a code to throw that right back in there. So yeah, again, these all have a class. They have a name. They have the image that is their sprite. We have the image armed. So when Link picks up an image, it's going to change the size of it so it looks like he's armed with that image, as in the case of like the wand, etc. And then whether or not the image is placed down on the map. Okay. So now moving back here, let's get into the more like significant part. So we've got all our sprites, we've got our classes, we have our sprites with their images, their XY positions, we have our grid with our grid tiles, their XY positions. But now let's go ahead here and get into how this game is actually generated. So we have everything we want to generate on the screen, but now we need the gameplay, right? So we go ahead here, and the first thing we're doing is creating instances of the game objects we want. So again, we've got Link, we've got the key events. That's just a separate class that is going to register all the key events. And then we've got our wand, our gold, our sword, our shield, our bow, Ganon, the portal, and temples, and Midna, okay? So that creates instances of all these objects that we're going to use for rendering to the screen, okay? Now, grouping games of related objects, this is essentially how we're going to put these objects together so that if we want to do a certain action on objects that are all of a certain type, or that all are of a certain like subcategory, then we have them in these lists here. We can iterate over those lists and do certain things to all of them, okay? So some basic configuration, we have our system fonts. That's for creating our health bars up at the top here. So you see Link Health and Ganon Health. And then we go ahead here and we've got our main game loop, okay? So for every game, you have a full game loop. This is what is happening while the game is running, okay? So we've got game over equals false, and then while the game is not over. So basically while true, and then if any game ending conditions occur, we set game over to be true, and then it'll close the loop. Okay, so we go ahead here and we say, this one here is just testing if Ganon is vulnerable based on the amount of beasts on the screen. So we're testing for the length of the beast list. And then this is our main user input loop area. So essentially within the game loop, you have an event listener, and that's for event in pygame.event.get, okay? And then that's going to listen for any kind of key presses or mouse events. So essentially here we have if you press the W key and the T key, you're going to transform into the wolf. If you press the key to move to the right, left, up, or down on your arrow keys, then that's going to move your character. And then we have space. You can press space to drop items, and you can press F to fire orbs, okay, out of your wand once it's armed. Okay, so then we go ahead and we have timed events. So let's zoom back out for a second, talk about the overall structure for the game. So again, for the game, you have your sprites, which are then brought into the game loop, that are going to be used in the game loop. You have your user events, which are any kind of user input that the player is doing. And then you have your timed events, okay? So your timed events are any kind of animations that you want to do, or any kind of things that happen without any kind of specific user input. So imagine it as if you have your keyboard and your mouse and your user's clicking on that, and the way timed events are set up is like some external input that the user can't press, but that occurs every once in a while, and when it occurs, it gets fed into that game loop as if like another button was pressed, right? So if you have like a user event for this example, we'll say we have a user event for moving Ganon, right? And that happens every like 400 like milliseconds or 4 seconds or something. So essentially what that is doing is that's got like imagine that as just an external button. We can't press it, but every 400 or every 4 seconds it gets pressed, and whenever it gets pressed, that gets fed into the game loop, and then that tells the game to trigger Ganon's movement, okay? So that's kind of how that works. So we've got if event type is user event, and the way you do this in Pygame is like this. So we've got pygame.time.setTimer, and then you have user event, and then the number of milliseconds. So 400 milliseconds, then yeah, I think it's something like that. 400 milliseconds would be like 4 seconds. So we go ahead and do that, and then that'll go ahead and that will set up the time for how your objects are moving in your game. Okay. So next up here we have, so these are the user events that are occurring that are on time. So we've got our orb path movement, our beast movement. So every once in a while, our beasts are going to adjust their position to close in on the player. We have the orb animation after that gets fired. We have the beast with the portal. So every X seconds, Ganon generates a new portal that opens up when the beast comes out. And then we have our Ganon's movement himself. Okay, so we're getting there. So now we've got our user events, our timed events. We've got our user input that is checking for. We've got all our objects rendered, or that are not rendered yet, but all our objects added into the loop here. And now we go ahead and we want to render our objects. So this is one of the last steps here. So if you imagine the frame, so we're building this game frame by frame. So it looks like it's happening in continuous time because the frames are being rendered so quickly. But essentially what you do is each iteration of the loop, it's building the very next frame of the game, okay? So in each loop, you want to have your conditions and your user events, check for user events, check for collisions, check for yada yada. Then based on that, update how your update. So this is imagine for the next frame, okay? So we're going to take a step back. I want to put this a better way. So we have our frame that is rendered, okay? So our initial frame, and then After that frame is rendered, it's moving through the loop, right? And it's checking for user events, game conditions, timed events. Based on those, it decides how it wants to place objects for the next frame. And then once it does that, it renders that next frame. Then back into the loop, check for events, decide how you want to place the objects based on those events, render the next frame, yada, yada. And that's how your game kind of progresses, okay? So we go ahead like that, and we've got... So right now we're rendering. So this is deciding how, but once our user events have occurred, we want to decide how we're placing the objects on the screen based on those events. So we have our render game grid. So that's going to be displaying our initial grid. And then on top of that, we want to render our hero, so Link. Then we want to render the temple, Midna, any beasts and items, orbs, etc. So the tricky part with rendering is that it's kind of layered, right? So if you rendered Link first, and then Ganon, and then the items, and then the grid, you wouldn't see anything on the screen except the grid, right? So you need to layer it. You need to render things as they're going to be displayed on your screen. Okay, so then that is that. So again, we're rendering our game grid, Link, temple, Midna, everything moving down here. Player inventory, that's another thing I had set up, but I did not decide to include. Basically, that's like a little chunk off the bottom of the screen where the items will go in there when they're picked up or in the inventory. And then we've got things like the trees, right? The trees are randomly generated. But the trees are a good example of this rendering, because if you think about it with the trees, we'll show you guys here. So with the trees here, you see how they're just kind of stacked, and none of them are like on top of each other in the sense that it looks like they were all rendered in descending order, right? But they're all randomly generated coordinates, and in the list they may not be in the proper order in descending on their y-axis, right? In order to render that properly. So we go ahead and we reorder those trees just to get them to look proper on the screen as they move, and that just shows again the rendering thing, how like you got to render things as you want them to display, thinking about how the environment is going to look. So after that, we go ahead, and this is the special line right here, pygame.display.update. That is going to re-render your entire screen with your newly updated frame, and then back into the loop, checking for game ending conditions at the end. So if Ganon's health is below 0 or if player's health is below 0, game over, you win, you lose, respectively. Okay. So that about sums it up, guys. That is kind of the overall structure for the game. If you guys have any questions, comments, definitely leave them below, because this is, again, there's a lot. Came out to be about 400 lines of code, so there's a fair amount going on here. If you guys showed enough, or if there's sufficient interest, or if enough people reach out, I will be happy to go through an entire walkthrough of making this game, adding some more functionality with some follow-up videos or whatever. Also, I'm going to show you guys how you can grab this code, play it on your own computer, and make changes. So if you guys want to collaborate with this on me, and like we can make changes and build this game together, that'd be cool. So let's go ahead. This is how you do it. So I'm going to have this link in the description. So you go to this link here, or you just copy it from the description, copy that, and then you want to open up your terminal or your command prompt, and you want to install Git, okay? So I'm going to leave the link for Git as well in the description. So you go ahead and install Git. It's going to be a little bit different for Mac, Windows, or Linux, but essentially all it is a command line tool for pulling down code from GitHub, pushing code up to GitHub, and keeping track of different versions of projects with different features. So, but we're only going to use a very basic part right now. And so once you've installed Git, you want to go ahead and open up your terminal or your command line, Git bash, I think it is for Windows. And then you want to say git clone, and then paste in that URL. And then it's going to clone down that. Then you click ls. So make sure you're in the directory you want to clone it into first. And then you click ls, or directory or folder. And then you want to go ahead and cd. So cd into Zelda game. ls, and then we're inside Zelda game. So now we want to go ahead and say pip3 install-r requirements.txt, and that will install all the requirements for the project. And then you go ahead and say python3 main.py, and that will pull up the game. All right. And again, guys, arrow keys to move. I'll probably put this in the Git repository, but arrow keys to move. Press W and T simultaneously to transform into the wolf. Basically go, you can't really do anything with the sword or the shield at the moment. That's something I was playing around with, but anyways. And yeah, go, in order to pick up the wand, you want to walk on top of that and avoid the beasts. Okay, so yeah, pick up the wand, walk on top of it. Where is it? There we go. And then go ahead and fire with pressing the F key, and it's going to fire in the direction that you're facing. Kill the beasts, hit them with the orbs, and then when all the beasts are gone, you can kill Ganon. Okay, so yeah, that's the summary. Yeah, so that's that. Once you have it cloned down, make sure you just install the requirements, open it up. Guys, hit me up with any emails or questions, comments, etc. in the comments below if you guys want to work on new features. Yeah, I'd love to hear what you guys think of this. It'd be cool. But yeah, anyways, thank you guys very much for watching. I hope you enjoyed this video. This was a cool project. I hope you guys learned just the general architecture for what creates a game. And yeah, if you guys enjoyed this video, thumbs up would be great. Please do subscribe. Thank you for watching, and have a great day, you guys.